Okay, thanks for stopping by. So this is me. I've been with NVIDIA for over 5 years now, and I am based on the border of North Yorkshire and Cumbria in the UK. Back in 2015, I was Europe's first deep learning solutions architect, their first female SA, but I now have a wider role encompassing everything to do with artificial intelligence, or AI, which is a huge field. As DevRel, I look after relationships with researchers from all over the globe. Let me turn off the sound from these. It's quite loud in my earphones. So today I'm going to talk about why gaming is so pivotal to the world of AI. We're very proud of our gaming roots. We love to showcase RTX, named for its ray tracing capability, upgrading the pixely world of Minecraft, but also offering that same incredible graphics to architectural design and even helping us go off-world. But NVIDIA is so much more than all this now. We are a platform company, a data center company, a GPU computing company. We provide end-to-end full stack expertise alongside all of our core work on computer graphics. But let's just rewind a little. Let's go right back to the early 80s, back to when gaming started to just get going. That's my big brother, Phil Hume. Now, 8-bit, as we call it today, is very simple. Less pixels means much less compute. Less actions, such as move forward, move left, move right, move backward, means much less complexity. So hopefully we can all remember this clunky world. But 30 years on, this is StarCraft, a complex game of strategy in the realm of multi-agent reinforcement learning. Here there are 300 possible actions that an agent could take, and assuming just a small screen size of, say, 84 by 84 pixels, that's already 100 million possible decisions to make. Complexity in gaming increases with its resolution, and due to the constant demands from photorealism from gamers and from AI researchers now, we have to keep innovating. Because these are the domains where we are literally teaching our artificially intelligent agents, or here a virtual PR2 robot. Isaac is our simulation platform with accurate physics where you can load up assets, create any environment and simulate absolutely anything. This is a screenshot from my colleague's VR headset. Here he's in the environment playing dominoes with the robot. He has full haptics, which allow him to pick up the pieces, and the robot is learning from him via stereo vision and reinforcement learning. This is a platform where we can help robots learn to interact with people, so they can safely play dominoes or pour a cup of coffee or assist our elderly parents or even perform surgery. Today's gaming is the key to putting robotics and AI to work in the lives of the world's 7+ billion people. And for 25 years, NVIDIA has been developing the hardware and software required to do this. The first graphics processing unit, or GPU, was introduced in '99. CUDA, its programming language, came in 2006, at which point the GPU could be programmed for any general scientific mathematical problem, not just graphics. So what you can do with pixels, you can also do with noughts and ones. AI at its base comes down to matrix multiplication. Simple mathematics, but with complexity comes scale in the number of mathematical operations. So we engineered and we re-engineered the parallel computing capability of the thousands of processing cores in each GPU system. No matter how the hardware scales, it still runs on the same singular software architecture, CUDA, bringing transformational capability across major markets. GPUs form the basis of all our platforms, such as Clara for healthcare, Isaac for robotics, Jarvis for conversational AI, Drive for autonomous vehicles, Metropolis for safe, smart, efficient cities, and many more. So this is our HQ in Santa Clara, California, closed now, except for essential work, including on Voyager, which is almost complete now. The fact HQ is closed doesn't alter our productivity at all, because everyone can work efficiently from home. Many of us, including myself, already did work from home. 16,500 of us all around the planet use technologies such as VPN access and GPU accelerated web conferencing, tools that everyone else has had to learn to use since COVID hit us all. Over at the back of this photo is Selene. Coupled with our existing AI infrastructure called Saturn V, Selene's 15 kilometers of optical cables and over 280 ampere based DGX superpods give us a peak aggregate capability of over 4.5 exaflops. That's 4.5 quintillion, 10 to the 18 or a billion mathematical operations per second. And this is what we do best. And we share how in white papers, and we demonstrate how by providing test facilities for you to run code. Go to the link here or simply Google NVIDIA DGX A100. Each of these nodes holds 8 or 16 of our 7 nanometer ampere chips, each with 40 gig of memory, each 20 times more powerful than Volta, its predecessor. But hardware means nothing without the software, and we spend a substantial amount of time and resources filling our central repo with optimized containerized code and making it available freely to all. CUDA-X is a collection of libraries to allow you to easily unleash the power of our GPUs, to increase productivity, to reduce time to insight, and completely change the timescales on which data science operates. A terabyte of time series data doesn't mean anything to most people. It's just an unimaginable amount of data until you see it. When the processing of that data is visualized, we can gain insight and understanding. This is a video of the full simulation done on a supercomputer scale of a supernova, over 1,077 time steps, computed and rendered in only 10 minutes on multiple DGX nodes with NVIDIA's Index software. But don't take my word for it. The MLPerf benchmarking site proves our capability across multiple applications: recommender systems, natural language processing, translation, and much more. GPU engineering brings down the time to compute, as well as the power and the cost to do it. Talking to our AI is imperative. Interaction with AI and humans is mutually beneficial and is the only way we will progress safely. Our Jarvis platform combines automatic speech recognition, natural language understanding, text-to-speech, Q&A, information retrieval, audio to face, and all our knowledge of computer graphics. So early access is now open for cloud-based applications. Conversational AI is fast becoming one of the most transformational fields within AI, but it's also the most computationally demanding. And the most popular and most deployed AI system is called the Transformer, hence why we named our language model Megatron. And this was a year ago, and it was pushing the boundaries then of what we could do to talk to an AI. GPT, or generative pre-training, combines transformers and unsupervised pre-training. Megatron had 83 billion parameters. But OpenAI's GPT-3 has 175 billion. It would take over 350 years to train it on a single Volta GPU. But luckily, we can scale linearly, and Ampere is 20 times more performant. So this lowers the costs all round across data centers. Today, this is Volta. Tomorrow with Ampere, saving time, money, and at 1/20th of the power, this is truly welcome in today's warming planet. Artificial intelligence is extremely important for our entire civilization, both on and off world. One of the first things I was involved in after joining NVIDIA was the formation of the Frontier Development Lab, or FDL, harnessing AI for all humankind. Every summer we run a super hack for 8 weeks, taking bold ideas and moving them to tech-ready level prototypes for space agencies and systems integrators. This image is part of the Moon for Good challenge, where we assisted teams at NASA in the search for water on the moon. Here we've rendered the irradiance field around the Faustini crater near the moon's south pole, which is permanently dark. Our real-time ray tracing technology allows us to literally see into these craters to simulate the physically accurate light paths. And this technology isn't limited to just visible light. UV and other forms of the electromagnetic spectrum could be traced too, with boundless applications across physics. One of the European teams, working with the European Space Agency, developed a prediction app for extreme rainfall, the kind that can devastate crops. In just 8 weeks, the team defined a usable, efficient app giving 5 days notice, enough time to harvest. It exploits satellite data and fuses it with various atmospheric, land and oceanic climate data for more accurate predictive forecasting, and it's coming to mobile soon. I'm very proud of FDL. It inspires pretty much everything that I do in the area of AI for good. And if anybody wants to get involved, please do contact me. I also get to work with a lot of space applications at NVIDIA. Earth observation data greatly enhances everything we do down here, whether it's monitoring how you open up public spaces in a COVID-19 world, understanding how traffic flows through a city or across an ocean, or even searching for other worlds. It all comes down to accelerated data analytics and prediction. Because AI is an extremely powerful discovery tool. We input data, we analyze it, the system learns features and finds patterns automatically, producing a model which we validate, and when ready, we deploy. And all of NVIDIA's software and hardware is optimized to do this very thing. On the left is the training, on the right, inference, or making predictions from new data. But this won't get us to human level intelligence, which is ultimately what we're all aiming to do, to artificially reconstruct our own intelligence. This is a hand drawing from Otto Dieters from 1865, showing the biological neuron, the cell body, the soma, and the synapses and the dendrites, how far we've come in just over 150 years. And neuroscience is now a key source of inspiration for safe AI. You'll all have heard of Uber, no doubt, extremely disruptive tech, but they also have an extremely cool AI laboratory. And this work initially started at Uber, then researchers moved to OpenAI in San Francisco. Open-endedness allows creativity into the AI system. And as Kenneth Stanley says, excuse me, it is biblical in its power, because it is the essence of creativity itself. Using insights from evolutionary progression, how we got to where we are today, this work allows a system to take stepping stones towards a truly optimal solution to any question. Because deep learning is just one stepping stone to reaching human level intelligence. Each step provides us with profound abilities and very valuable tools. Think how the mobile phone changed society and the market that it created. There is nothing on this planet more powerful than giving humans the assistance of AI. In my work, I also collaborate with multiple robotics researchers around the world, and NVIDIA has a very large division focused on this area of AI, from pure research to impactful deployment. This is one of our labs in Seattle. And what we gain from gaming is the virtual world, a risk and cost-free environment where we're not just able to teach behaviours, but teach thousands of agents in parallel. This is work with Carnegie Mellon using GPU acceleration in sim, running what's called distributed reinforcement learning, a very powerful technique similar to how we learn, where the agent is given a goal and it learns how to reach that goal by itself through extreme trial and error. Starting from simply random movements, it learns how to stand, to walk, and then to interact safely with others. Running on a single Volta GPU, just see how quickly it learns. And that's the link to the paper there. And so gaming is now the domain used to teach thousands of AI agents how to collaborate, how to achieve goals, or how to just play, because that's how we learn. Within the realm of Dota 2, agents can even time travel. They took only 10 months to cover the equivalent of 45,000 years of self-play to beat humans. This is actually the human player Padgecat playing against OpenAI's system a couple of years back. He eventually lost, unable to keep up with a system that can absorb hundreds of human lifetimes of experience every day. Over the decades, of course, we've spent a lot of time simulating reality. This is the basis of gaming, where physics is accurate and where virtual worlds become real. And with our Isaac platform, we can simulate any environment. We can design, simulate, train, and deploy all in one platform, and it's free to download. These are just some of our fleet of sim robots. We have plenty of real ones too. And this is a screenshot of part of the digital twin of BMW's production factory in Germany. They use this exact simulation, an exact replica of their facility to safely train and test all their robotic devices that automate many of their processes. So whether you're designing a self-driving car, building robotic assistants, making movies, or designing incredible architecture, we've built the world you can do it in, and we call it Omniverse. Running on DGX multi-GPU systems, on EGX for AI at the edge, or RTX. And it has all the photorealism that you would expect from us. But now we're also able to look and simulate the entire planet. Our JETSON range of embedded GPUs power hyperspectral images in the International Space Station. This is an image of East Timor from Orbital Sidekick, one of our partners, which ran their JETSON-based system nominally on board the ISS for over a year. They're about to deploy a second-gen payload, providing a high-frequency monitoring solution to all. Our JETSON range allows a vast community to utilize the parallel computing capability of GPUs. And we also provide free teaching kits to universities too, so reach out if you need those. All the software is freely available online for applications across the spectrum of edge computing, for drones, for medical images, for intelligent cameras, intelligent satellites, for inspection, for disaster response, global awareness. And here are some more resources. I'll post a copy of these slides on Twitter today too. All of the software is designed for simple deployment to be cloud native. So this utilizes our central repo of software that we call NGC. Code is packaged in Docker containers, lightweight, standalone, executable software that includes everything needed to run an application. Code, runtime, system tools, system libraries, settings, and it's all completely free. So go ahead, get online and test. It's software that allows you to run any and more of these applications on low swap or size, weight and power deployments, such as this using a single JETSON Xavier to run deep stream software and capable of processing 30 high definition streams simultaneously. Or in the ultimate edge device, this is mission critical AI where human lives are at stake. And over the years, we've created a huge data set from our own small vehicle fleet running around the roads of California, but augmented with masses and masses of simulated data. And we've put papers out into conferences, proving that combining real and simulated data improves performance versus using just real data. The system can also dream up so-called corner cases, so the unknown unknowns, so the real car itself can handle, or the robot itself can handle any unexpected situation. And it's how BMW's smart robots can conform fully to all ISO and safety requirements. All of this together, it's how we can race to find a cure for COVID-19. Harnessing AI helps us tackle problems so much quicker and much more thoroughly. Oxford Nanopore is able to sequence the virus's genome in just 7 hours using our GPUs. The handheld Mini in here measures tiny ionic currents that pass through nanoscale holes called nanopores. It offers portable, real-time, low-cost reads, computing using our JETSON TX2, so even for people without any bio skills. So please sign up for all of our latest software on DevZone, where you'll find solutions to many problems. And I realised that was a ton of info. So if you'd like further training on any of this, please get in touch or go online to our Deep Learning Institute. Our curriculum spans fundamentals right through to industry-specific applications, teaching you how to build and deploy neural networks for a variety of tasks. And if you're a startup using GPU-accelerated AI, sign up to our support program Inception for hardware discounts, access to technical experts and global sales and marketing assistance, for example. So we will be staying virtual till spring 2021 at least, but all the talks from our recent GTC and the upcoming October conference are available online. You can use this code to get a discount to access that. And I'd like to leave by saying that I fully support African AI from research to deployment. If you're a researcher who needs help and you're deploying, for example, with a company, reach out because we have support programs. But the Great Rift Valley was the cradle of our entire species 300,000 years ago. And Africa should be at the heart of the AI revolution too. Please make sure that you listen to my friend Alex Sardo's talk later today for lots of events happening across Africa. And I'll be available in the speaker lounge for Q&A. So Harambe, thank you.